Welcome to this explainer. If you've ever wondered how modern tech giants just update their apps seamlessly without the whole system crashing down, well, you are definitely in the right place. Today, we're demystifying the absolute core engine of modern software development, the CI CD pipeline. We're going to navigate the entire software delivery lifecycle by thinking of it like a highly optimized factory assembly line. Think about it. Top tech companies are literally deploying code thousands of times a day. So today, we'll explore the machinery building that code, the safety valves preventing total disaster, and the control panels used to measure success. Okay, let's dive into this. Look at this quote from a 2007 study. It perfectly captures the historical tension here. For decades, deploying new software was this terrifying manual process everyone dreaded called merge day. Literally a day filled with merge conflicts, broken code, and, just sheer panic and way too much coffee. Moving from that manual, error-prone safety net to a fully automated assembly line completely flipped the script. And it introduces our core narrative hook for today, that delicate, absolutely crucial balance between maximum speed and absolute safety. So here's our roadmap for the factory tour. First, the heart of CI CD. Second, strategies for safe deployment. Third, choosing the right tool. Fourth, measuring pipeline success. And finally, mastering multi-cloud integration. Section 1. The heart of CI CD. To really understand our factory, we need to clearly define the individual stations on this automated assembly line. So the CI stands for continuous integration. In modern development, you've got multiple developers working on different features all at the exact same time. Without CI, they build in isolation and then try to mash it all together at the end, which is a total nightmare. CI fixes this by breaking large projects down into small, iteratively tested tasks. Developers are constantly merging updates back into a shared trunk, which instantly triggers automated tests. It basically ensures you have a fundamentally sound application at all times. Nobody is stepping on anyone else's toes. Next up is the first flavor of CD, continuous delivery. Once your code passes that continuous integration phase, continuous delivery automates the release of that validated code right to a repository. The really crucial takeaway here is that the code base is always ready for deployment, it's totally production ready, but, and this is key, it sits waiting for a manual push. That manual gate acts as a final human safety valve before the customer ever actually sees the update. Then we have the second meaning of CD, which is continuous deployment. Now this is a much more complete form of automation. Here, every single approved code change goes automatically live to production. No manual gates, no human intervention whatsoever. Because changes are going live instantly, this demands an incredibly high standard of automated testing. In this stage of the assembly line, your automated test quality is literally your only safety net. If your tests are bad, your release is bad. Section 2. Strategies for safe deployment. Let's move to and see how this builds. Because if we're automating releases, we really need to know what safety valves keep us from accidentally taking down the entire system. The most straightforward approach is a basic deployment, where you just update all your nodes with the new version at the exact same time. But man, this is highly risky. If there's a bug, every single user experiences it all at once, and rolling back is painfully slow. Now, contrast that with a canary deployment. This strategy releases an update incrementally, so say to just 2% of your users first. It lets you safely test in production with real users. If the canary survives, you roll it out to 25%, then 75%, and the whole shebang. It's the lowest risk method out there and gives you a really fast rollback. And this brilliantly illustrates our next strategy, the blue-green deployment. In this setup, you maintain two completely identical environments. Your green environment is live, handling all your actual user traffic. Meanwhile, you deploy your shiny new code to the blue environment and test it out thoroughly. Once you're confident it's good to go, you simply flip a switch and instantly route user traffic from green over to blue. If something unexpectedly breaks, you just flip the switch right back. It acts like an instant undo button. The main catch, though, is that replicating your entire production environment like this can get pretty expensive. Section 3. Choosing the right tool. Now that we've got a handle on the safety strategies, let's evaluate the physical machinery of our factory, the actual platforms that power these pipelines. We've got two heavyweights in this space, GitLab CI and GitHub Actions, and they have very distinct philosophies. GitLab CI uses a single configuration file and really functions as this all-in-one, enterprise-grade DevOps powerhouse. It is fantastic for complex pipelines that need advanced security or features like merge trains. It does have a steeper learning curve, though.
GitHub Actions, on the flip side, uses multiple workflow files and natively integrates right into your GitHub repo. It really shines because of its simplicity, its event-driven nature, and this massive marketplace of pre-built actions that you can just plug directly into your assembly line.
Section 4. Measuring pipeline success. Because, let's be real, having a highly automated CI CD pipeline is virtually useless if you aren't actually measuring its health. To get a complete data-driven picture of our pipeline's health, we divide our focus into 3 distinct categories. First, quality metrics, which measure how effectively we're producing release-ready code without bugs. Second, automation performance metrics. These reveal whether our automation is actually speeding up delivery or if it's just introducing operational risks. And finally, infrastructure dependability metrics, which confirm whether our underlying servers and networks can even handle this kind of high-frequency delivery.
A prime example of a quality metric is the defect escape rate. Basically, this is the number of defects or bugs that get caught in production compared to the ones caught beforehand during pre-production testing. If this rate is high, it means your safety nets are failing. It's a huge red flag signaling an urgent need to shift left, meaning, introducing testing and quality checks much earlier in the software development lifecycle.
Under automation performance, we look really closely at deployment frequency. This measures exactly how often a DevOps team successfully deploys code to production. It serves as the ultimate indicator of your pipeline's overall throughput. Let me tell you, a high deployment frequency combined with a high success rate is the absolute hallmark of an elite engineering organization. That's exactly what we should all be aiming for.
So the crucial point is understanding how infrastructure affects all of this, which brings us to MTTR, or mean time to repair. This dependability metric measures the average time it takes to recover from an infrastructure failure. If your MTTR is high, well, it means pipeline disruptions are taking way too long to resolve. This directly throttles your deployment frequency and significantly extends the time it takes to actually deliver value to your users. Keeping MTTR as low as possible is a constant, ongoing goal.
Section 5. Mastering multi-cloud integration. For this final stage of our explainer, we're taking our machinery and scaling it up across multi-cloud environments.
Running deployments across AWS and Azure simultaneously introduces some massive management headaches. The secret to actually making this work? Standardization. By implementing unified infrastructure as code and standardized security platforms that span multiple environments, teams can dramatically simplify these complex deployments. It helps control costs and lets you seamlessly move workloads between AWS and Azure as needed, avoiding that dreaded vendor lock-in.
Now, what's really interesting about this workflow is following the journey of a single piece of code. It starts at the engineer's workstation, moves through Visual Studio, and seamlessly integrates into Azure repos for version control. Then, it passes through automated test plans and finally deploys via Azure pipelines. Standardizing this entire tool chain creates a highly predictable loop. It eliminates human error and vastly speeds up the delivery process.
As we wrap up this explainer, I want to leave you with a bit of a provocative thought. We spent this time talking about automating the assembly line of software delivery. But today, artificial intelligence is beginning to actually write the code itself. AI is going to generate an unprecedented massive volume of code. So the question is, who or what ensures that code is delivered safely? If your CI CD factory pipeline struggles with human-generated code today, is it truly ready to handle the autonomous, AI-driven future of tomorrow? It's definitely something to think about as you evaluate your own systems. Thanks so much for joining me on this deep dive into the software assembly line. Keep learning and keep optimizing.